Hi guys, it's Mrs. Seitz. Today what you're going to be learning in lesson 5.4 is something called function notation. Function notation is just a different way to name a function that is defined in an equation. For an equation in x and y, the symbol, and this is what function notation is, it's called f of x. It replaces basically the y in the problem, and it is read as the value of f at x, or the way I will always refer to it as f of x. You never, ever, ever say f times x, okay? So it's read f of x. A linear function can be written in function notation, and it's like instead of y equals mx plus b, you might see the y replaced as f of x. You can use letters other than f to name a function, so you could see things like g of x, or you could see h of x, okay? But they are all basically replacements for the variable y, okay? So to evaluate a function at a given variable, you write the original function, you substitute x with the number that is given to you, and then the value that is given takes the place of the variable that's in the function, and you basically simplify. So here, let's take an example down at the bottom. We're going to evaluate a function at each one of these values when x equals 2, 0, and negative 3. So for example, in the first function, we have f of x equals 10x plus 1. So the first, we're going to evaluate this function when x equals 2. So I'm going to, according to these directions, evaluate it by plugging in a 2 anywhere I see an x. So I'm going to evaluate this f of 2. So I'm going to plug in a 2 here and then do order of operations. So f of 2 would equal 10 times 2 is 20, 20 plus 1, 21. Okay, I'll do the next one, f of 0. So 10, replace x with 0. So 10 times 0, 0, 0 plus 1 is 1. All right, and the last one, we'll do f of negative 3. So 10 times negative 3 plus 1. So let's see, 10 times negative 3 is negative 30. Negative 30 plus 1 will equal negative 29. Okay, you do the problems the same exact way. Who cares what the letter is in the front? So the next function is g of x equals 3x plus 6. So I'm going to evaluate this function at 2, 0, and negative 3. So g of 2 would be 3 times 2 plus 6. So 3 times 2, 6. 6 plus 6, 12. We'll do g of 0. And you'll get 6. You can do g of negative 3. And you'll get an answer of negative 3. Okay, we'll do the last one also. I have to go do this up here at the top. So h of 2. So 0.75 times 2 plus 8. So that would give me an answer of 19 over 2. We're going to do the same thing when x is equal to 0. So 0.75 times 0 plus 8, which will give me 8. And h of negative 3. So 0.75 times negative 3 plus 8. And I'll get an answer of 23 over 4. Okay, and what's nice about all this too is you can check your answer. So if you are asked to evaluate a function for x and you need to figure out what these values are going to be, you can always fall back on that table button. So let's evaluate and check these answers for when f of x was equal to 10x plus 1. If I push our table button and I type in 10x plus 1, back in example 1, and I go down to ask x. I just care about when x was 2, the answer should have been 21, and we got that for f of 2. All right, and then when x was 0, the answer for f of 0 was 1, and it was. And when x was -3, the answer for f of -3 was -29. So you can see, you can go in and check your answer for these problems if you are given the answer for x to evaluate, okay? You're not always given that, so you have to be careful in how the problem is written. All right, in these ones, you're still given x, and we have to evaluate the function when x is equal to -1 and -2. And it says here to be careful with negative bases when you substitute into fractions with exponents. I know we haven't done much with exponents, however, you do have your calculator, and I am going to show you guys how to do this. So we're going to evaluate each one of these functions for these. So let's evaluate, and let's say that this is maybe f of x. So we'll say f of -1 equals, and we'll use our parentheses when we plug in, -1, keep your exponent on the outside, minus 2, parentheses, -1, minus 10. Okay, so let me go to my calculator right now and make sure I don't make any sign mistakes. So I'm going to push the parentheses button, type in -1 inside the parentheses, hit the parentheses button to close it, and then type the exponent on the outside to make sure I don't mess up the sign. So -1 times -1 will give me +1. All right, then for the second part, -2 times -1, well, I know that that's +2. And then bring down your minus 10. So 1 plus 2, and then that's going to give me 3, and then 3 minus 10, that's going to give me -7. So f of -1 should equal -7. All right, we're going to do the same thing, except we're going to evaluate this function for -2. Okay, so anywhere I see an x in the problem, I'm going to evaluate it when x is equal to -2. So -2 to the second power minus 2 times -2 minus 10. So again, we're going to be really careful with our parentheses. So parenthesis, -2, and the parenthesis, exponent of 2 goes on the outside. You can see when you evaluate -2, the quantity of -2 to the second power, you get +4 on your calculator. So we would get +4. -2 times -2 gives me +4 again, and then minus 10. So 8 and 8 gives you 8, 4 and 4 give you 8. 8 minus 10 gives you -2. So f of -2 equals -2. Okay, we're going to check our answer like I showed you guys before. So we're going to go to the table button. We're going to check it with x squared. So we're going to type in x, here's the exponent button, x squared minus 2x minus 10, hit enter. We're going to go to the Ask X feature, hit OK. And again, I want to see when x is equal to -1, what my answer should have been. And it is -7, so we got the right answer for the first one. And I'm going to check it again when x is equal to -2, and it is -2, so again, we got the right answer for that one as well. Okay, so see how that table feature is very, very helpful to you. All right, let's try this one. Okay, I want you guys to put in your notes that this is g of x is equal to -x minus 5x minus 15. All right, we're going to evaluate this g of x for when x is equal to -1 again. Okay, so g of -1 . Okay, we're going to substitute in -1 anywhere we see the x in the problem, and we're going to be really, really careful with the exponents. Okay, All right, so in here we know that -1 quantity squared is going to give us +1. So I'm going to bring that part down because I know that this is equal to +1. But I still have like that -1 that's hiding on the outside. So this is really -1 times +1, which is going to give me a -1 overall. Okay, so let's actually make sure that that's right in our calculator. So if you're ever unsure, you can go back and just literally plug it in. So let's get out of the table feature. We're going to type in our calculator exactly what we see. You can see that's giving you -1, okay? So if you're ever doubting yourself, plug it in, okay? -5 times -1 and -15. So we're going to get an answer. Let's see, that's 4. 4 minus 15, that's going to give me -11. So that means that g of -1 equals -11. Okay, we're going to do the same thing, except this time we're going to just evaluate when g is -2. So the opposite of -2 quantity squared minus 5 times -2 minus 15. Oops, I'm running out of room. There's a 15. Okay, so -2 times -2 is 4. 4 times -1, that's going to give me -4. -5 times -2 is +10 minus 15. And overall, that's going to give me -9. So g of -2 would equal -9. And again, we can use that table feature to help us. So again, on the table button, clear out what was in there. We're going to type in -x² minus 5x minus 15. Hit enter. Okay, and we're going to type in -1. We should get -11, -2. Hit enter. We should get -9. It's a really useful tool to help you. All right. The other part that you're going to have to evaluate for, and you have to read very, very carefully, sometimes you have to solve for x. Okay, so they're going to tell you what g of x is equal to. You have to work backwards to see what x is equal to. So to do this, you're going to substitute the given value in for the function, and you are going to solve for x. So the example says to find the value of x, so see how the directions change up, so that the function has the given value. Okay, so notice how the problem looks a little bit different. So it tells you the function is g of x equals 3x minus 8. So I'm going to write that down again. Then they tell us that g of x equals -5. So it's almost like they're telling you in the problem the y value is equal to -5. They want to know what x value that's occurring at. So we're going to plug -5 in totally for this whole entire g of x. See how the problem already looks a little different? Okay, so when we solve for that, we know we'd be adding 8 to both sides. So we would end up with 3 equals 3x, and then we would be dividing both sides by 3, so we would end up with x equals 1. So the final answer for this one is x would equal 1. So we're not writing g of anything on this one, we're looking for just a final answer in terms of x. So x is equal to 1. All right, let's take a look at the next one. It says h of x equals -1/2 x plus 3. So I'm going to write that part down. Okay, and then they're telling us that h of x is equal to -1. We need to basically figure out what's the x value when that y value is equal to -1. So we're going to plug in -1 in for h of x, and we're going to solve for x. Okay, so we're going to subtract 3 to both sides. So when we subtract 3 to both sides, we would end up with -4. Okay, then we have to clear that -1/2 that's with the x, so you could divide both sides by -1/2. When you divide both sides by -1/2, you're going to get an x answer of 8. So with these ones, the only way that you would be able to check these ones is to actually check your x value in the problem. So like we could go back into our table button, and like for this last problem, we can type in -1/2 x plus 3, the original problem, and we can search the answer we came up with. So x equals 8, and we can hope that the y value is equal to -1, and it is. Okay, so you won't be able to search for the y values. You can only search for your answer, which is x equals 8, and hope that it pops up together. Okay, so see how the little wording is a little bit different? Okay, the last part of what we're going to be doing today involves graphing. So let's take a look at a graph and see how you can evaluate a function on a graph. It says when evaluating a graph, remember f of x stands for the y value. So locate the given part of an ordered pair and then find the missing part by locating where you're at on the given part of the graph. Okay, so it says here that for part A, given this graph of the function f of x, find, and then it says each one of these things. Okay, so we know the y value is kind of like f of x, right? And x is still x. So if we know the x value is equal to 2, we want to find what's f of 2. So what's kind of like the y value when when x is equal to 2. So what we're going to do is we're going to go over on the x-axis to 2 for our first problem. And let's see, here's 1, here's 2. We're going to see where we link up on the graph whenever we hit that graph. So here's 2 on the x-axis. I'm going to go down, 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 down on my graph. Okay, so here's a point right here on the graph wherever I am hitting that graph at an x value of 2. I have to see where at on my graph on the y-axis, f of 2 that I'm hitting at. So I'm going to draw a little line, kind of like when we were finding the range of the function, where that's hitting at. Okay, so what value am I at right here? Well, if you guys look, that's at -2. So at f of 2, I am on the y-axis, f of 2, I'm at -2. Okay, so again, I'm just kind of changing up my wording. So when x is equal to 2, or f of 2, I'm looking at a value of -2 on the y-axis on that graph. All right, let's go to when x is 0. Okay, so when I'm at x equals 0, which is right here, where am I at on the y-axis or f of 0? Well, I'm right here on the y-axis, right? So if you were to draw that line, you're hitting right there at the origin again. So f of 0 is at 0, if you're drawing that line. Okay, let's look at f of 5. So let's look on the x-axis at 5. So 1, 2, 3, 4, 5. Okay, so here's f of 5. Okay, we need to go down and see where we hit at. Looks like we're hitting right here on our graph. Okay, so I'm going to draw the line and see where that's going to hit on my y-axis at. At f of 5. Okay, so look here. Looks like that means that's going to hit at -1 on that graph, right? On the y-axis. So f of 5 would equal negative 1. Okay, let's keep going. Okay, let's look at f of negative 5. So here's negative 5 on the x-axis. Okay, where am I hitting on the y-axis, or f of negative 5? Boom. Looks like I hit right at the origin, so f of negative 5 would be equal to 0. Okay, so that was for letters A through D because the problems look very, very similar. Wording changes up, though, on E and F. You have to figure out what x is when the y values, or f of x, is equal to negative 2 and 0. So we're going to work backwards. Okay, so this time I'm looking on the y-axis. So when y is equal to negative 2, so here's negative 2 on the y-axis, or f of x, right? So here's f of x when it's equal to negative 2. What x value does that occur at? That's the question. Okay, well, if I look very carefully, right here is where that occurred. And if I follow that up on the x-axis, it occurred at an x value of 2. So my answer for that one is x equals 2. Okay, let's do the same thing. I'm looking for an x value this time when I'm given the y value. So f of x, kind of like our y value. So f of x is equal to 0. I want to see what x value or values does this occur at. So it hits right here and it hits right here. So what are those two values? It hits at x equals negative 5 and it hits at x equals 0. So two locations. Okay. The last part, it says an equation of a linear function given h of 1 equals 6 and h of 4 equals negative 3. If you think about this, we're not using this graph. This is actually a little bit of a challenge for us. So what I want us to do is think about what these actually stand for. The number that's inside the parentheses is actually kind of like your x value. So I'm going to write that as an ordered pair. The number that's here at the end, the equal sign, that's kind of like the y value. So h of 1 is equal to 6. So that really stands for the ordered pair 1, 6. If I have h of 4 equal to negative 3, it's kind of like the ordered pair 4, negative 3. If you guys have two ordered pairs, you certainly know how to find a slope and a y-intercept. So if you do your slope formula, negative 3 minus 6 and 4 minus 1, you're going to get a slope of negative 3. And then you can do y equals mx plus b to get your y-intercept. So I'm going to do that up here. If I choose the first ordered pair, 6 equals negative 3 times 1 plus b. So negative 3 plus b equals 6. If you add 3 to both sides, 9 would be your y-intercept. Okay, so if I'm trying to write a function in terms of h, we know the slope is negative 3. We know the y-intercept is 9. The last step, instead of writing a y, there's an h in the problem, right? So I'm going to write h of x equals negative 3x plus 9. So that would be your answer to letter G. Okay, the last part of your lesson today is to make some comparisons about some functions, okay, in terms of how much a graph is shifted up or down on a graph. These are called vertical translations. So how you're going to determine that is by taking a look at your y-intercept. So it says the graph of f of x plus k is a vertical translation of the graph f of x where k cannot equal 0. So for example, if we started with the black line and we shifted up a couple units, that would take us to the blue line. And that couple units that we went up is indicated by whatever that value is here by plus k. If we started at the black line and we went down a couple units, whatever that value is that we went down a couple units, that would be whatever that value would be in red. Okay, so in vertical translations of a graph of linear functions, the graph will have the same slope but have different y-intercepts. So we are going to be focusing on y-intercepts when we take a look at vertical translations. Okay, so it says to compare the graph to the graph of f of x equals 1/4 x. So you can see your steps for making the graphs exactly from what they are for graphing a linear equation. So you can choose any of the ways that you've done in the past with making a table of values, using slope and y-intercepts, graphing with your intercepts. Okay, it's up to you whatever way you want to. Okay, I always prefer to do slope-intercept form, but we're going to be making some comparisons between those two graphs about how many units up or down that they are shifted, okay, from the graph f of x equals 1/4 x. So I know the slope is 1/4. I know the y-intercept is 0. So I'm going to do this one in black. So I'm going to start at 0, and I'm going to go up 1 and over 1, 2, 3, 4. Make my ordered pair. And graph. Okay, so there's the first function, f of x, and I want you to label it f of x. Okay, in the first one, we have same slope, 1/4, but our y-intercept is -5. So that means I'm going to go down 1, 2, 3, 4, 5, but I'm still going up 1 and over 1, 2, 3, 4. So all this question is asking you to do is talk about how many units up or down this graph has shifted from the unit that we have done, or from the graph that we have done from f of x. Okay, so if we compare k of x, which is 1/4 x minus 5, to the original one that we did in black, f of x, which is 1/4 x, how many units did it shift down? It shifted 5 units down. And how can I look at the problem and know that right away? I can look right at my y-intercept. That is the main difference between those two problems. This one has a -5 in the original problem, and the f of x did not, so I know that that one is going to be a difference between 5 units between the two. Okay, let's take a look at m of x. M of x has a slope of 1/4. It has a y-intercept of 3, so that means I'm going to start 1, 2, 3 units on the y-axis, go up 1 and over 4. So m of x would be right here. So when you look at the y-intercept, the difference is it's a +3. So that means in comparison to the original function f of x, it is shifted 3 units up. Okay, so when we're making some comparisons of the graphs, we're thinking about how many units up or down it has shifted, and we make that comparison by looking at the y-intercept. All right, so we learned a lot in today's lesson. We've made some comparisons of graphs by looking at y-intercepts, and we've looked at what is function notation. So sometimes with function notation, you will be solving for x, and most often with function notation, you'll be solving for the y in the problem, which is going to be looking a little different, right? Function notation is read like this: f of x, g of x, or it could be h of x. We've also seen it look like on a graph as well. Okay, so if a question is looking like this, where it's like f of 2, you have the x value, they're asking you to find the y value in the problem. So you need to be really careful with your notation. Just remember the fancy looking f's that you could see in the problem now, they really stand for the y's overall.